to understand this game, I think it's not a bad idea just to try it out. So let's say x goes with 1, y adds 2 to get to 3, x then adds 2 to get to 5, y adds another 2, x just adds 1, y adds another 2, x adds 2, y adds 2, x adds 1, y adds 2, x now adds 2, and y can add 1 to reach or exceed 20, though they could have added 2 as well, so they're guaranteed to win at that point. So y is 1 here, and we need to start thinking what would ensure a winning position. And there was a problem then when we got to 17. When x was on 17, they couldn't reach 20, but they had to add either 1 or 2 on, which meant that y could add the other amount on to get to 20. So that is a key position to get your opponent to, so that you can win. So to ensure y ends up on 17, well, let's think about this. So to get to 17, 1 onto 17, if y is on 14, then y will either add 1 or 2 on, and x can then get to 17. So basically we can just keep minusing 3. If we get y onto 11, then whatever y adds, we can make the total up to 3. And then 8, 5, and in fact 2. To ensure y ends up on 17, x can make sure y ends up on the following checkpoints. So x starts on 2. Whatever y adds, x makes the total of the 2 turns equal 3. E.g., y adds 1, x will therefore add 2, and vice versa. Then repeats. So to follow pattern above, y takes turn on 2, then 5, then 8, then 11, then 14, then 17. Y adds 1 or 2, so x can then obtain or exceed 20. Using this tactic, they will always win. So I hope that makes sense. I did an example of a game, and I saw that the problem lied at 17, because whatever the person adds, the other person can then get to 20. So if we can get the person to 17, the opponent 17, then we can definitely win. But how can we get the person to 17? Well, if we get them to 14, then we can use the same idea and then get the total up to 17. We can work our way back as I indicated here. and then just put some explanation in and justified why x can always win by starting with 2 and basically adding 3 every 2 turns. Part 2 modifies the game slightly so that now you can either add 1, 2, or 4, and the x can start with either 1, 2, or 4. So what I decided to do is look at each of the numbers and decide whether, if you landed on that number, whether you would be in a winning position if you had your go on that number. So if you're on 19, then you can necessarily win because you can just add 1. 18, you can just add 2. 17, actually, you can still win because even though you can't make 20, you can exceed it. So you can just add 4. 16, you can add 4 as well. So if you get any of these numbers, you're okay. But 15, you will necessarily, well, your opponent can make you lose because you can only get between 16 and 19, and then your opponent can win. So for 16, we're going to lose. If you end up on 14, then you can make sure you win because you can just add 1 to get to 15. Same with 13. But if you go to 12, then you can't get your opponent onto 15. You can only get them to 13, 14, or 16, and then they can make sure they win. So 12 is another losing position. 11, you can win because you can get them onto 12, and the same with 10. So you can see this pattern, how this pattern's working now. Right, let's just fill in the rest. So with 9, again, you're going to lose on 9, or at least your opponent can make you lose because you've only got the option of 10, 11, or 13, and then those are winning positions. 8 and 7, you can win. 6 is going to be a losing position. Then 5 will be a winning position. So will 4. 3, we can't actually get 3, I think, because x can only choose 1, 2, or 4. So 2 and 1 will then be, can you win? So if you're on 2, you can win because you can get the person onto 6. But if you're on 1, then you'd either go to, sorry, you can get to 3. You just can't start on 3. So if you're on 3, then it's going to be another losing position. So you can win on 1 because you can get the person to 3. So this time, if x picks 1, 2, or 4, then y can make the total equal 3 or 6 and put x in a losing position. Because if x goes with 1, they can add 2 to get them to 3. If they go with 4, they can add 2 to get them to 6. If they go with, if x starts with 2, they can add 4 to get to 6 as well. And then whatever now, so y then ensures that the sum of the 2 turns is 3 or 6. Up to 15 to ensure that the checkpoints above are followed. So if x starts at 3, sorry, starts at 1, then y can add on 2 to get x onto 3. X then, say, adds 4, then y can add 2 to get them onto 9. If x then goes with 2, get to 11, y can add 4 on to get to 15. We always have to make sure that they get them onto 15. There's no way that as long as they get onto 9 or 12, see, because if x adds 4 here, then they get to 16, but then y could add on 4 after that. So I suppose I should just add that. Y then ensures that some of the 2 terms is 3 or 6 up to 15, up to 12 or 15. Ensure that the checkpoints are followed. If x has a turn on 15, then y can win by making a total greater than 5. If x has a turn on 12, then y can either make the sum 3 to get to 15, or 8 if x chooses 4 to then win. I just wanted to really clarify that they're either adding 3 or 6, but you have to make sure that at this point, if x is there, then if x adds, you'd never add 6, you'd never get to 18. It's only if x chose 4 to get to 16 that y would then choose 4 to get to 20. If x chooses 1 or 2, then y would choose 2 or 1 to then get them to 15. So therefore, y can always win. These change of rules has turned the tables around. The official solutions go into a lot more detail. They actually give like an exact tactic for what to do if x chooses a certain number. And again, you can see that they're either going up by 3 or 6s. Okay, and they basically like follow a little route through to ensure that y wins. So I didn't do that, but I feel like I justified it enough by writing down these losing positions and explaining how y would get there. Really interesting problem. Nice little tactic that we can make in each case. Well done on this challenge, and I hope this makes sense. Keep going.